Good afternoon, ladies and gentlemen. Thank you for joining us for today's MarkLogic Vision event on Agile integration of data. It's part of our metadata series, second one in the series that we've done. The first one covered metadata. Why is it important? How do we capture it? What do we do with it when we've got it? And what value does it bring to the business? And hopefully you saw in that event that it brings context, meaning, and insight to your data to help make your data machine interpretable, not just machine readable. Today's session is now about how do you access that data? How do you get that data to the BI applications, the systems or applications that you're developing on, where that data can make a difference to your business? Joining us today will be John Snelson. He is actually one of the key architects behind the design of the MarkLogic Optic API. He smiles there in deference, but he is definitely one of the people that were behind this initially as an internal project, and now formally supported by MarkLogic. So it's great to have him on. John, without further ado, I'm going to pass the baton on to you.
Great.
We'll crack on.
Thank you very much. I just get my presentation going. Okay. So the title of this talk is Agile Integration with the MarkLogic Optic API. And we're going to be going a bit more technical with this presentation, looking at some of the ways in which you can query the metadata that you have and get value out of that. So to introduce myself, my name is John Snelson. I am Director of Technology at MarkLogic. And I have responsibilities for managing the query team, the core server query team, and also for leading the product architecture team that oversees the architecture of all of our products. If you've watched the previous webinar in this series, you may recognize this graphic, this screen. We talked a lot about metadata in the last webinar, and hopefully one of the things you came away from that with is that metadata is valuable data. But the important thing as well for querying this is that metadata is actually just data. It's data about data, but it's still data. So what's different about metadata, and why does it deserve a different kind of consideration when you're looking to query it? So one of the things I'd suggest to you is that metadata is sometimes in kind of non-standard shapes. When I say non-standard, I suppose I mean it's in a different shape to your original data, and it maybe uses a different data model. So it's quite often graph shaped. You get RDF data, which details the metadata about your documents. You might have tabular data. In fact, we've got a couple of different examples in this graphic. We've got feedback scores, which is tabular data here. We've got domain knowledge, in this case about relationships and things, but that's in the RDF graph. And so because metadata often comes in all sorts of different shapes and formats, it's really important to have a query language or a query capability that allows you to query both your data and your metadata, and therefore both your documents and your graph and your tabular data. You need to be able to do that in order to make sense of all of that data together. In the MarkLogic ecosystem, of course, Semaphore can produce RDF metadata, that's graph-shaped metadata. And actually, it can also mark up the documents that it reads and give you interesting information marked up into the documents as well. And when you're looking at where you store and find the metadata, and sometimes that metadata is in the documents that you're storing. Sometimes it's not in those documents, it's in a standalone separate document, or in separate graphs that, where the documents really don't matter. It's the graph that you've imported. And so you need a way to be able to combine the data, not just of different data models, but from different documents and different sources as well. And so for that reason, MarkLogic as an agile multi-model database makes it a lot simpler for you to get value out of your metadata. So just by way of introduction, I'm sure you've heard MarkLogic described as a multi-model database before, but how does our flavor of multi-model work? So at our core, MarkLogic is a document database, and we store documents. And different indexing techniques, in this case, the diagram is showing template-driven extraction to produce views from those documents. Those views are stored in the indexes in MarkLogic, and they're tied back to the document at all times. And so that has some really important benefits. When you secure the documents, the indexing artifacts that come out of those documents are also secured. So if you can't see the document, you can't see the document's contribution to the graph, and you can't see the document's rows in a tabular form, a tabular view. So that is pretty important to simplify your kind of governance of your data there. There is, the search interface and search query language you can use to find documents without knowing too much about those. And as well as the relational query engine that allows you to do so much more across lots of the different data models that we can store. And I should say as well as template-driven extraction, which is an indexing technology, so it does, it does require a re-index to use template-driven extraction. There's also now query-based views, and we'll have a little look about what those can do later on in the presentation. But essentially, they allow you to take a query and to save that query and say this defines a new table. And that happens. Query-based views is a runtime technology, so you don't have to re-index to use query-based views. Okay, this is my big architecture of MarkLogic server slide. There's a lot of information on here, and some of this is, fodder for future discussions, I suspect. I can't possibly cover all of this right now. But one of the things I want to really draw your attention to and double click on today is the query engines that we've got over this side of the slide. You'll notice that I've called out the search engine as being separate and distinct to the Optic engine, where the Optic engine is a relational query engine in the standard sense of that term, in the sense that you might find in a relational database. So it deals with tables and it deals with joins and other things like that. But if we just double click in on just the query part of this, you see there's a lot of functionality in the search engine, including full text indexing, indexing of structure and metadata, security, and many other things that is capable of. But at its core, the search engine qualifies or disqualifies documents as a whole. So a document either matches your query or it doesn't match your query. So and the results of that query are whole documents. And you can see that works by sending a CTS query that defines that what the question that you're asking to the dnodes, and it's sending fragment IDs back. Now, when you read fragment IDs, you can also think document IDs for most purposes. So we're sending back the IDs of the documents that match, and if you're processing that result, then it will fetch those documents for you as you process. Now, by contrast, the Optic engine has a lot more functionality. but it requires you to do some upfront work. So the search is available on documents as soon as they're ingested, whereas you'll have to define in a lot of cases how you want tables or graphs to be kind of pulled out of your documents and allowed to be queried to use Optic Engine. But the same engine actually runs underneath Optic API and SQL and Sparkle, and in future underneath the GraphQL feature that we're planning to release as well. So it's the same engine, just running different surface syntaxes. And that engine works by arranging subtrees of the query plan to send to the D nodes to execute, and it fetches back rows of a table. So it works, using a different query technique, basically. So let's dig a little deeper. What's the point of this Optic API? So there's a little fragment of Optic API down here. This is the JavaScript syntax. And that's, in fact, what I'll be using through the presentation. But Optic API is a multi-model query language. And so because MarkLogic supports multiple data models, and we needed something that went beyond SQL and something that went beyond Sparkle to be able to give our users the full power of MarkLogic. And Optic API is that. It is a consistent and idiomatic API in the target languages. And so we have server-side implementations in JavaScript and in xQuery. And in the client libraries, we have JavaScript and Java implementations of Optic API. When I say idiomatic, that means it looks and feels like the language that you're using it in. And it uses something like a fluent style to chain function calls together to help you to build up the pipeline, which is the query that you want to execute. Now, because it's declarative, so you're telling us what you want to know, not how to figure it out, that means we can use cost-based query optimization to figure out the best way to execute your query for you. And because it gives you access to all of the multimodal querying capabilities that there are in MarkLogic, it is a kind of a one-stop shop for querying MarkLogic. And so if you learn the Optic API, you should have a way to access all of the different querying techniques that MarkLogic gives you. So Optic API uses this pipeline definition that you put together by chaining calls to the API. And the output of every operator or data source in that pipeline is as a table, or you could think of it as a sequence of rows. And some of the operators can take tables as input, one or two tables, but they all produce tables as output. And so the result of an Optic API pipeline is usually a table. And the values in the cells of that table can be simple scalar types, but actually MarkLogic is flexible and allows you also to put sequences or arrays or nodes into the cell values of the query as it's executing as well. So we can fetch documents. Those would be nodes. We can process collections of data from those documents by using sequences and arrays as well. Now, Optic API also has some kind of special magic ingredients, which make it much more useful in the MarkLogic ecosystem. And one of those is that it has a representation for fragment IDs, or again, our read document IDs, if you like, in that place. So those fragment IDs uniquely identify a document, but without fetching its content. And so there's a couple of things you can do with fragment IDs. Obviously, you can fetch the content, the actual document, using them. and that can be really important. So for a given row in a table, you can say, hey, fetch me the document that this row has come from, and MarkLogic is able to give you that very efficiently. Another technique is joining. This is a key technique, actually. It's used quite a bit. If you join based on fragment IDs, say from one data source and another data source, then that kind of equates to getting information from that comes from the same document. And so if you've got tables and graph data in the same document, you can find where they coincide, find where they come from the same document. Another interesting special type is row IDs, and they uniquely identify a row in a TDE view, and they can be quite useful for doing certain types of queries as well. Just as a kind of overview of what's in Optic API, we won't go through this in detail. We'll pick up on some of these later in the presentation, but there are a few categories of operators in Optic API. So you've got a data source. Those will be what you start your Optic API queries with. You've got access to all of the different kind of places that you might get data from in MarkLogic, all the indexes and data models. Then you've got operators to process those in certain ways. There's post-processing map and reduce functions where you can just pass in your own kind of post-processing functionality. And then there's all sorts of different ways in which you can use the pipeline. There is a result which gets you the answer, which is probably the most often used one, but there are other ways in which you can use those pipelines. So you can look at the query plan for them, or you can generate a query-based view using them. So what we're going to do with the rest of this presentation is take you through some use cases and how you use Optic API, how Optic API provides you with functionality to fulfill those use cases. And it kind of makes sense to start with search queries, because very often our customers, the first thing they'll need to do with their data is do a bit of data discovery. They'll need to load their data and find out what they've got. Query it, figure out what the structures are, and start to understand how they're going to use the data they pull from lots of different places together to produce the results that they want in their application or in their decision-making process. So because search is so important, and because there is search made available to you in MarkLogic straight out of the box without defining any indexes, it kind of makes sense to look at that and look at the universal index, which is a kind of proprietary MarkLogic index that does our full text indexing for us. Now, if you look at this document that we've got on the screen here, because this document is marked up in, well, this is a human language content document, so it's probably marked up in XML. We can tell something from the tags, property names, element names that are in there already. So we know that this whole document is an article, that it has a title and a footer. We can find paragraphs, features like unordered lists, and also features like tables, if we know what the markup dialect means. And in fact, there are words in there, of course, and that goes back to the kind of original purpose of full text indexing this document. So the universal index can index all of these kind of features of the document without being told what to do or configured in any way. And that means you can answer some fairly rich queries just using the universal index. So for instance, we can say get tables from computer science articles that include a title with the word content, but not the word agility. Apparently, we're not after agility today. So you've got all sorts of different categories of information, not just about words, but about the structure of that document. And in fact, the universal index recasts a full text index, which you might find in other search engines, as a fact index. And we can store facts about any number of things. So one fact might be the document contains the word content. And another fact might be the document contains an element named table. And we can store all of that information and therefore answer quite complex queries. Here's a slightly simpler query here. So we're looking for a word query for the word content, but not the word agility. And if this is our fact table or our term list, our term table in kind of full text indexing terms, you can see that we want to include the documents with the word content, and we want to exclude the documents with the word agility. Those document IDs internally, they're kept in numeric order. And so you can see that we can do a quick scan of those numeric fragment IDs and filter out the ones that are in the agility list and come up with our solution for this query. The universal index, as well as just doing structure and full text word content of your documents, can also index a large variety of different things. And some of them include things like directories, hierarchical directory naming, collections. And in fact, MarkLogic security is stored in the universal index as well. It's a CTS query that's automatically added to whatever you ask MarkLogic to do based on what user you're accessing MarkLogic as. So how would you do search in Optic API? We're going to see a number of slides that look a bit like this, and each one of them introduces a different functional operator from Optic API. So in this case, we've got from search docs, and that very simply takes a CTS query to execute. And what it does is it gives you back a 3-column table, as you can see down here at the bottom. You've got the URI column, document column, and the score column. So that's allows you to get either the document or the URI and the score assigned from that search query. So you can use that for simple searches. But that's actually a helper function implemented using a couple of other pieces of functionality in Optic API, from search and join doc. So from search is the more general API here. And in this case, it's similar. It still takes a CTS query. So that is the definition of a full text query. I'm actually not going to go too much into detail about what CTS queries can do, because there's actually quite a lot of material out there that we've published about those. And we have to cut short in some way for this webinar. But yeah, so you can see from search, and in this case, it's not fetching the actual document content. It's giving you access to that fragment ID. It is a little bit of a power users feature, which is why the helper function is useful. But you can do even more with from search if you are confident and know what you want to do with it. So other columns here include score, confidence, fitness, and quality, which are all of the different values that you can get out of a CTS search or a search if you're used to dealing with those APIs. So this gives you access to all of those different columns as well as the fragment ID, and it doesn't fetch the document content. So you'd use either of these two to start an Optic API pipeline to give you some data to start processing before, to figure out your final result. As well as just executing a search and getting results, often in a search application, you'll want to have something like facets in the sidebar. And so there's an operator called facet by. This is another helper function. It's actually implemented using other parts of Optic API. But very simply, this is just going to return you one row. And it's going to have columns for each of these named groups that you can see in the facet by in the example here. And those are going to have arrays. And what we're looking for is unique values in those columns that we're accessing. And we're going to calculate counts of how many times those unique values occur. And that will allow you, that will give you the information you need in order to provide a facet sidebar for your searches. Now, facet by is a helper function, and underneath the covers, what that's doing is using a group by to do, to group by the columns that you're talking about. In fact, it uses a multi group by. I think it's called group to union in Optic API. But group by is a much more general operator, and you give it an array of columns which define how to calculate whether the group is the same or not, and an array of aggregates that you're going to calculate on those columns. So here you can see that the aggregate that we're calculating is sum over those columns. I think that square bracket's in the wrong place. So I think that's a typo. So apologies for that. So yeah, you can, I mean, this is a little bit unlike SQL. SQL allows you to scatter your aggregate functions throughout the query. But here you can see that there's a direct association between the grouping operation and the aggregates that get calculated. And so the columns that we'll get back from this group by include a column for each of the grouping keys and a column for each of the aggregates that we're calculating. So when our customers have got a search application up and running, and probably they've added facets to that as well, one of the next things that they often want to do is provide some kind of semantic layer on top of that search and make that search more responsive to what the user is actually asking and what the data actually means. So first, a little note about meaning. What does it mean to say that we understand something? Now, if you look at this cartoon here, as you begin looking at it, eventually you realize why it's funny. You notice that there's a cat with wooden legs. You notice that there's a piranha here, and maybe you associate cats with kind of dipping into fish tanks, trying to catch the fish that are in there. And then eventually you figure out how the cat lost its legs. And you groan and you chuckle inside a little bit, I suppose. But it's that application of domain knowledge, things like cats like fishing for fish in a fish tank, that you combine with the input, which is what you can simply see in the picture, that provides you with meaning, which in this case makes the cartoon funny. So let's just talk about a use case of one of our customers. This is a website that is designed to help you find manufacturing standards. So they've got a full text index over all of these big documents which contain manufacturing standards for what you might manufacture. And in this case, our domain is healthcare and healthcare devices. Now, if I say something like, find me standards that apply to manufacturing cardiac catheters, those words actually appear in very few documents. However, with a bit of domain knowledge, we can understand what a cardiac catheter is, and we can understand that it's a subtype, a narrower category, that and an instance of an implanted device, a medical device that gets put into somebody's body and left there. And if we know that it's an embedded device, then looking for standards that apply to embedded devices it means we know that those are directly relevant to the what's been looked up. So with a domain model, and applying that domain model to the query that's asked, we can actually get greater recall. We can give you back more documents that are relevant to you by applying that domain knowledge. So here's what that kind of might look like. I'm not representing that this is actually how the customer solved this problem. But the techniques that they would have used, they would capture that domain model in RDF. So in this case, cardiac catheter has a broader concept, and that is catheter. And a broader concept than catheter is implanted device. So here, when we have our query string from the user, well, the first thing we'll do is we'll look up those query strings and see if we can find concepts in our domain model that match them. So we might run a Sparkle query that looks a little bit like this, and it's going to follow 0 or more broader transitive links to find concepts that are related. And then we can execute those here using from Sparkle. So this is Optic API that we're looking at here, using this Sparkle from above. And we can fetch all the related concepts. And then those concepts we can pass into a query like from search docs, which will allow us, and yeah, actually we're using the synonym option, which means that they get weighted as identical in the results. So that affects the scoring that we do. But then you've got a search, which takes into account not just the text that the user wrote, the words that the user wrote, but also related concepts from our domain model. So here we've used from Sparkle. And this is interesting. This is an Optic API call that allows you to directly embed a Sparkle query. Now, in this case, you're restricted to Sparkle queries that return tables, because if you recall, Optic API always returns tables from its operators. But in this case, because there is the regular Sparkle query form returns a table, that's fine. We can take that table and we can perform more Optic API operations on that table that gets returned. And that Sparkle query is turned into Optic Engine operators alongside any other Optic operators you may subsequently use, and it's all optimized together as a single query. So that can be an efficient way of writing the query using Sparkle, which is a good domain-specific language for querying the RDF graph. And it allows someone who knows Sparkle to write the Sparkle part in a query language which they understand and which they're very familiar with. So that can be really useful. Just a quick note about how that query or how Sparkle queries match in graphs. When you've got a Sparkle query like the one we see on the right, there are actually 3 triple patterns here. Where we've got question marks, that's a question that we'd like to find the answer to. So our query actually looks like this yellow graph here. You can see each of these edges. So there's author wrote book. There it is, author wrote book. And the author is speaking at this conference that I'm going to there. And I like the book that they wrote. So we've got the data in the graph up here in blue, and we've got the pattern, the query pattern, and we need to find parts of the graph that match that pattern. So you can see that it matches up here. And having matched that pattern, we can figure out a table which gives the answers, 1 row per set of matches. And everywhere that we wrote a question mark, we get an answer. So here you can see that there's a particular author speaking at this conference. And I might want to go and talk to him because I'm a fan of one of his books. So that's how Sparkle matches and how matching in the graph works in MarkLogic. There is another Optic API operator to do that. If you want to stick more firmly in kind of Optic API and not branching out into Sparkle queries themselves, there is an idiomatic API for accessing the triples and doing simple pattern matching in the triples in the graph. Okay, I want to take a moment to describe template-driven extraction, which is the indexing technique that I described as we first started to talk about multi-model in MarkLogic. So template-driven extraction can be used to turn document content into either table rows or into triples. And that happens at indexing time. So if you add a new triple to, a new document to the database, then TDE might get involved to process that document to find the triples in the way that you've described, to pull triples out of that document, and it'll add those to the indexes. And I talked briefly about the advantages for security when all of the index entries are linked back to the documents they came from. There's a number of different benefits to that, but another one is that when you remove that document, all of the artifacts that are indexed and derived from that document also get removed as well. So you have kind of less maintenance to do then to go and clear up the derived artifacts from removing that information from your database. One of the other advantages of using template-driven extraction is that you may have multiple different document formats. You may have JSON, you may have XML, you may have multiple representations of the same type of information in different XML formats. And you can write a template-driven extraction. You can write a template that targets each of those different document formats, but all contribute to the same named table or the same vocabulary of graph. And that can be a way of understanding those different document formats together. Just briefly, if you're doing, if you're writing a TDE template with a document that looks a little bit like this, if you want to extract triples here, you're going to have a template that looks like this. We've got the context path that tells us which documents to run this template against. And then we've got this triples section, which defines for each triple how to fetch the subject, predicate, and object. Now, this expression here is in XPath syntax. And you can use all sorts of different functions. So here, for instance, I'm grabbing the document URI and turning it into an IRI for the subject of my triple. Whereas for the object of this triple, I'm grabbing a value and casting it to an integer from the document. And here we've got essentially a constant for the predicate. We've just $EX would have to be a kind of a template constant, which you defined further up. But we're just using that to prefix that IRI. And then once that triple's been materialized in the index, we can ask questions about it. So this is a SPARQL query, and this is an Optic API query that would access that triple. If rather than pulling triples, which are the edges of the graph, out, if you wanted to produce a table or tabular structure, you could also do that using template-driven extraction. So you've got the same context, but then you give the table that you're producing a schema name and a view name, and you define for each column in that table, you define what it's called, what its type is, and then the expression that helps you to find the value to put into that column for this given row that you're producing. And you can produce multiple rows from any documents or single rows. It's quite flexible in terms of how you pull out information from those documents. But once you've got that data indexed, you can use, for instance, SQL to access that table, or you can use Optic API to access that table as well. So let's look a bit at tables and joins and how those might be used in Optic API. Now, in this case, we've got a use case that I know the BBC have used on their sports webpage. Now, when you look at the page for, in this case, Chelsea football team, you can tell some things about the information on here. So, for instance, you can tell that we've got an article about Lampard, and we know that he plays for Chelsea. So that article is on the Chelsea page because Lampard plays for Chelsea. This may be a little bit old, and I also don't know much about football, so you can criticize the fact that maybe he doesn't anymore later on. So you can also see that Chelsea plays in a particular league. So that's some information you know about the football team. And you can tell for a given fixture, for a given match, Chelsea were the away team in this match, for instance. So with a domain model, like to describe how teams work, who the members of those teams are, what leagues they play in, things like that. So we've got this RDF graph that tells us all of that information. But in this case, we're not doing semantic search with it so much. We're not using it to expand the information we fetch from search query. What we're doing is we're using it to put together a page of really interesting information about that topic. So if we pass in the topic, in this case, the IRI for the football team, we might go and say, well, let's find all of the matches that they play in. Let's find all of the people that play for them. And we might also, this is leagues that they play in, and this is matches that they have played in as well. And then you could piece that together with Optic API. Now, just a little note about what's going on here. We've assigned the view to a variable here in JavaScript, because we're going to use that twice. We're going to join against that view, and we're also going to use it to qualify which columns we're talking about. So here we're saying the tag column of this view, and that's kind of a nice way that you can use Optic API to fully qualify your columns. So here we're running our Sparkle query to find all of the different concepts, all of the different entities that we'd like to pull in to make a page on the given topic. In this case, we're imagining that the tags for various articles are stored in a table. So we're accessing that article tags table to pull in the tags for those topics. And we're fetching, join.doc will fetch the document for those topics. In this case, we're using the URI column to fetch the document. And then we can provide the result. And in this case, this results method actually executes the query, but we're passing in the value of team to the query. So that will replace this question mark team with the value that's passed in. So it allows us to pass in externally bound information to that query. So what Optic API calls have we seen being used here? We've got from view, which just gives you access directly to a named table. Now, very similar to the from clause in SQL. And you've got join inner, which is doing a regular inner join. We've got the table that we're joining against, and this op on, which defines which columns are join conditions for that join. And Optic API has a full range of different types of joins. So you can just look at this. Really, I'm not going to go through each one of these, but there's a large number of different types of joins that are available for your use. We also saw join.doc. Join.doc takes either a URI string or an IRI or a fragment ID, and it knows how to fetch the document content for any of those types of values. And so we're going to add a new column called doc, which actually contains that document content with this call. And similarly, we've got join.doc URI. So if you don't want the content, but you do want to fetch the URI of the document, you can use that, and you can get a column with the URI of that document. Now, we are running a little bit late on time, so I'll run through this fairly quickly. But one of the reasons why we did Optic API in the first place is because we wanted to provide customers with a way to connect to the BI tools that they want to use. And most of the BI tools speak SQL and connect to databases with ODBC. And so Optic Engine speaks SQL. We implemented SQL in that. And that gives you access from your BI tools to TDE-defined tables. And you can also use query-based views to define a table that the BI tools can access. So query-based views are actually really interesting in this concept. So you can take an entire Optic API query, use generate view to generate a document and store that into the schemas database. And that makes that view available under the name that's given. So here it will be main people. But the interesting thing here is I'm taking a Sparkle query, and Sparkle, the BI tools don't speak Sparkle. But by using a query-based view, I can take a Sparkle query and save it as a query-based view. And now the BI tools can see that as a table, and they can access the data from that. And that happens at runtime. We're still executing the Sparkle query at runtime, but it gives the BI tools a way to view your graph data. And so that's kind of, in fact, it's good for Sparkle and RDF data, but it's good for all sorts of things, actually. You may want to give your analysts a cut-down view or a pre-joined view of different data that you've got, and query-based views allow you to do that as well. So we saw Optic API calls from SQL, and you can use SQL in your Optic API pipeline as well. Obviously, SQL returns a table, so just like Sparkle, we can just take that table that the SQL returns and add more Optic operators on top of that if we want to. So again, if you're familiar with SQL, there's no real reason why you shouldn't use SQL, at least in part for your pipeline, and you can keep your query in the query language that you're most familiar with and able to use most effectively. Okay, so coming up, we've got a few interesting new features coming out in MarkLogic 11. We're actually in the processes of rounding off the MarkLogic 11 release. So although I can't speak about release dates, it's coming very shortly. One of those features is geospatial support in Optic. Now, we've had geospatial support in MarkLogic for a while now, but there's a specific geospatial region index which you have to enable to turn that on. And what we've implemented for MarkLogic 11 is that the triple index, which sits behind both RDF data and triples and actually behind our TDE tabular views, the triple index now supports geospatial regions. It can store them, it indexes them, and it makes them available to query. And so if you have TDE tables with geometries in, you can, well, not only can you now store the geometries in a column of a table, but you can query those and find rows of that table based on geospatial constraints. And the same is true for RDF triples. They can contain geometries regions as their object as well. So there are geospatial operators which we've now exposed in Optic API and in Sparkle, and that's GeoSparkle, if you're familiar with that spec. And there's also SQL GIS support and ODBC support for querying and returning those geometries. So here you can see an Optic API query, and it's got a geo contains constraint based on this polygon that we're passing in from up here. We're finding rows of that view where the geometry column matches is contained inside that polygon. And it also means we can connect to various interesting geospatial tools. This one is QGIS, running using an ODBC connection directly against MarkLogic data. So that's an interesting and very useful new feature that's in MarkLogic 11 coming soon. One of the other features that we've been working on is Optic Update. Now, this is in technology, well, will be in technology preview in MarkLogic 11. What that means is that we are still adding new features to it. It's production quality, what we're releasing in MarkLogic 11. We don't consider the feature to have been finalized and finished yet. We're going to be doing some more work on it to enable more use cases. But in this case, we've got an Optic API pipeline here. The interesting thing is we've got this write function, and that works using document descriptor rows. So it uses, for instance, the URI and collections and doc columns to define which documents to write, where to write them, or what collections to put them in. So there are well-known names for those columns, but you can pass in alternate names if you want to. And this is an interesting query. It's searching for docs in the staging collection. It's fetching the sub orders. So let's say your document has a number of order elements in it. Maybe you want to access each of those orders as a separate document. So we're accessing the sub orders, each of those orders. We're unnesting them, which means we're creating a row for each of those. And then for each of those, we're figuring out a URI and which collections. So in this case, we're putting it into the final collection and we're writing those documents out. So we've turned one large composite document into lots of smaller individual documents, one for each order, which it just goes some way to showing the flexibility that you can get from Optic Update if you're describing the updates that you want to have done to your documents using that facility. So as well as what we've seen here, you can remove documents, you can transform documents. We've seen this query, which starts with a search to find the documents we want to process. You can also pass in the initial documents. So you may have a list of 10 or 20 in your application. You can pass those directly in as the kind of starting input for your Optic API pipeline. Okay, that's just a brief overview, a little taster of what's coming up in MarkLogic 11. But hopefully you have had a good overview now of a lot of the different kinds of things that you can accomplish in the Optic API and the ways you can use that to pull different data together to provide the application that you want to provide. With that, I will say thank you very much for your time and pass it back to Phil, who's going to handle the questions for us.
Cheers, John. Thank you very much. Yeah, it was a really good, detailed description of the MarkLogic Optic API. We're already, using this with our customers to help them solve challenges within their business. I had a customer just this week who was able to address a problem that he was having with the search optimization, and has actually come back and said it was 2 times faster than his previous solution. So we're already solving these challenges, and it's really good to see that we're evolving the product as well going forward. So yeah, really good. We've got a question in the chat here, and if you've got any questions, please feel free to post them. If you've got anything after the event that you would like us to discuss, either reach out to us at csm@marklogic.com or go on to marklogic.com/digital-acceleration. And that'll get you to the digital acceleration page where there's a question and answer box down the bottom there to answer any questions. But the question goes, if we need a bunch of pieces of data per record to respond to a query, we could have a template define a view with many columns, or we could have a view with few columns and join the documents. Can you talk to the trade-offs? Is there a number of columns that would be too many?
Yeah, okay, let's talk to that. So when you store tabular data that's indexed using TDE, we actually we have an interesting hybrid data format when we store it on disk, which allows us to either go and fetch entire rows directly from the disk, or we can fetch entire columns directly from the disk, or a bit of a mixture of the two. So some of you who are used to relational databases may recognize that as a row-based DBMS storage format and a column-based or columnar database-based format. We've got both, and we can choose which one we use based on what seems best for the query. The optimizer chooses between those. So here, some of the trade-offs are this. So if you need to fetch the entire row, having more columns means that fetch takes longer. But at a certain point, we won't fetch the entire row. We'll just fetch the columns that you ask for. And so we can reduce the data access we do by fetching, just 3 columns from 50, and we can be quite fast at doing that. So to some extent, it doesn't matter too much how many columns there are in the table. It can be a really good technique to have some columns indexed and in a tabular view, and then fetch the document to get all the rest of that information out. But fetching the document content takes a certain time, and you get a great, the whole document. If you wanted less than the whole document, you may find that, say you just wanted 1 value, probably fetching 1 column is quicker. If you want 10 values, I don't know where the cutoff point is. There'll be a point when fetching columns is faster, and there'll be a point where fetching the document is faster. So I like the question. I think it's a great question, and you're asking the right, you're thinking about the right things there. But I would run a couple of experiments just to see how that works time-wise. I mean, MarkLogic won't use columns that you don't access in the query. And so you're paying disk space for indexing those columns, but you're not paying time in the query usually if you're not accessing the columns. So it can also be a technique to index too many and, kind of see what gets used. You could always cut back later, I suppose, during the development process. You could choose to do that. Hopefully that answered your question.
Yeah, I hope so. I think it's a good answer there. There was a question around how easy is it to now learn another tool that we have there with the Optic API? How easy is it for developers to pick up on this? If they're a SQL developer, they've been SQL for forever. How is it when they come into a business and say, right, okay, now you've got to learn the Optic API?
Yeah, that's a good question. So, I mean, every NoSQL database and their aunt has been releasing something that they call a SQL-like query language over the last few years. And the cynic in me suggests that SQL-like just means that you type select and then do something else after that. However, Optic API has been designed to be familiar. If you're used to using SQL, then it has been designed to be familiar. Although it is a new API, and you might have to learn the kind of way that you piece that pipeline together. The concepts are the same, but more than that, if you know SQL and you're accessing tabular data, you can just use SQL in it. And if you know Sparkle and you're accessing graph data, you can just use Sparkle. And so hopefully it bridges that gap between domain-specific, knowledge about SQL querying or RDF querying with Sparkle, and still allows you to build using other Optic API operators, which may be more specific to the way that MarkLogic does data modeling and multi-model data. Everybody groans when they have to learn something new, but my hope is that Optic API is simple to learn and is reusing concepts that you'll already understand before you start learning it.
We've got another question that comes in. It says, do we have a query tool that uses the Optic API, or do we have to do everything via code?
Yeah. So yes, I mean, Query Console these days actually has an Optic DSL dialect dropped on in the drop down. So if you select that, it will treat what you're writing as Optic DSL. Now I should explain that a little better. We have defined a subset of JavaScript and a whitelist of MarkLogic functions, which you can pass in as a string query. And it's basically designed to let you use Optic API, but not let you use arbitrary JavaScript or arbitrary functionality in MarkLogic. So it is essentially a string syntax for using Optic API functionality. And so what was the original question? I need to refer back to it.
That's all right.
So that we have a tab for that in Query Console. And that will do syntax highlighting, and it will do tabular views of output for you, and it will allow you to click through and examine the graphical view of the query plan. So yeah, it's quite powerful actually. You can even execute the query, and the query plan can be annotated with timings and memory usage and things like that for that running query. If you're looking at tools outside of the MarkLogic ecosystem, no, I don't know of any that deal with Optic API right now. But I mean, we saw connecting to BI tools, for instance, using ODBC and SQL, and that can be quite powerful, particularly in combination with TDE and query-based views to define interesting tables for those tools to work with.
Yeah, actually, I saw the Query Console in action the other day about the cost associated, viewing that cost, and actually, it's really simple once you understand the process, and it gives you that direct feedback as well, so you can really optimize those queries. So yeah, it is a really good tool. We're coming up to the hour now, and I'm conscious of time. I don't want to take up any more than we already have. But I'd just like to say thank you very much to John for his time. Thank you to Jeremy for our previous session on metadata. You can view both of these on demand on our Bright Talk channel. Coming up at the end of the month is a MarkLogic demo with one of my colleagues, Dave Cassell. He's actually going to talk about MarkLogic end-to-end, including Semaphore, including the Optic API, and then bringing that data into a BI tool. And he's going to take you right through from the raw data to the BI view. And it's a really interesting, really powerful demo. So definitely recommend that you check that out. If you subscribe to our channel, you'll get notified when that's live. But please feel free to register that, because I think it's really interesting. Coming up in December, we've also got another session. We've got a customer spotlight session with one of the leading academic universities who are going to be talking about cross libraries and bringing those together, bringing these cross collections together from various different sections of the university to power basically a more advanced search. So that's going to be really interesting as well. And as John mentioned, we also have MarkLogic 11 coming up, shall we say, shortly. So keep an eye out for that. Subscribe to the channel, and we'll make sure that you get notified of that as well. But John, thank you very much for your time. Thank you everybody for joining us today, and we hope to see you on the next one. Thanks very much.